This conference will now be recorded.
Hello friends and good morning, and let's start. Today's session, right, we're going to start a new topic which is container systems, guys. So not, I don't say it is a Docker, I can say like it's a container systems. So we're going to discuss today about what exactly is containers and how exactly Docker can be installed, as well as I want to explain about what exactly difference between a virtual machine as well as a container, because most of the people which I came across, right, they think that a virtual server like a EC2 instance or a virtual machine in Azure, right, is similar to a container, which is exactly not true. So first let's talk about how exactly a container is different from a normal virtual machine, and then we go ahead and install the Docker, and then we're going to talk about like how actually create a container and everything. Okay, so first thing is the most important thing is we need to understand what is the difference between a virtual machine, difference between a virtual or virtual machine and container. If you understand this one, right, then everything will be easy for you. That will be very good exposure to you. Okay, let's do one thing. Let's deploy a machine here. Now what I'm trying to do is in the EC2, right, and I'm going to deploy a Ubuntu server. Okay, so what I'll do, I go here, and we did a lot of times, right, so it's not a big deal, but you need to understand underlying what exactly is happening. Now when you click on launch instance, and I'm going to select the Ubuntu 16.04, and T2 micro is enough, and select your VPC and select your public subnet 1 and give some sort of a random IP. I'm going to give 100. So add storage, add tags, name, I'm going to say simply server 1, configure the security group, launch it. Okay, now what exactly is happening at the backend? Now a EC2 server is actually getting launched in AWS. Now can I call this EC2 server as a container? Absolutely not, because it is not a container. In order to understand that one, let's understand what exactly happening at the backend. Okay, now this server is deployed in availability zone called 1A. I'm not going to really cover what is region, what is availability zone, guys. We crossed that a long back. So let's imagine I'm going to take a availability zone. I'm going to open a paint, and imagine this is the US East 1A availability zone. This is, I'm just taking one availability zone. This is US East 1A, East hyphen 1A availability zone. Now in this availability zone, what is an availability zone? Availability zone will have a lot, it's like a data center which have lot of racks and servers. Now inside this one, imagine I have a rack, actually a server rack. Now I'm going to call this basically server rack, actually. Okay, I'm going to call this a server rack. You just Google server rack, you'll get a lot of pictures. Okay, inside the racks, right, you will have a lot of physical servers. So I'm going to take one physical server, right, so for testing purposes, right. So I'm going to take a one physical server. Just imagine this is the physical server I'm talking about. This is a physical server I'm talking about. Now in the physical server, so can you directly launch the instances, EC2 instances? No. See the physical, how exactly a physical server looks like here. If I go to HP DL 380 Gen 10 server, right, and if I go to images here, right, the physical server looks like this, guys. Okay, a physical server looks like this. See the physical server, I can say like our empty laptop without any operating system. If I show it to you, right, see this is a physical server, and it is not having any sort of operating system. That means you can't literally run any VM on this one. Similarly, I don't say AWS using HP servers. Similar to that one, they have their own customized servers. Okay, so now you have a physical server. Inside the physical server, you need to have an operating system which is actually called as hypervisor. Okay, inside this one, I'm going to put operating system which is actually called as hypervisor. See, this is the green one is the hypervisor. So what exactly hypervisor does? Hypervisor has a capability of virtual machine. I'll explain what is hypervisor. So hypervisor. So what are the different types of hypervisor? Like VMware, vSphere, Hyper-V, and AWS at the back end, they are using Citrix Xen server, which is developed by Citrix actually. Now inside the hypervisor, now you will have the virtual machines. This is what happening actually. Now when you create a EC2 server, what is happening is this is where the VMs are getting created. This is where the VMs are created. So I'm going to say, so let's me put like this. I say EC2 instance, or I can call VM, simply VM1. Okay, you can actually call this way. Similarly, I'm going to keep this here as well. Okay, this is VM2. Now this is basically is getting created the backend instance. Now these instances, right, they can have different operating systems. So whatever you are seeing right now here, the instance, right, it is actually creating at the back end. What is happening, this is what happening at the back end. Now this can be Windows, for example. It can be different operating system, right? So this can be Windows, guys, and this can be Linux. Okay, that means even they are actually virtual machines deployed on a hypervisor, which is on a physical server. Still they are actually having their own individual operating system. Now what will happen if you want to deploy an application, Java application or .NET application, whatever the application, if you want to deploy it earlier before container systems, right? So you need to create the VMs like this. Either if it is a cloud, you need to create the EC2 instances. If it is in your on-premises, right, you have virtualization like VMware as well as Hyper-V. You can actually create the VMs like this. Now, well, there is a problem with this one. See, it's not actually a problem. But I can see like the problem here is, or I can say like the challenge here is every server, right? You know, for example, I take this Windows server, for example. If you want to run this Windows server, obviously not, I'm talking about application, guys. Leave about application, I'm not yet installed the application. Just to run this operating system, you need the OS disk, you need to have the CPU, you need to have the memory. Okay, and you also I can say like additional things are the network and everything. But if you see, you need to have these things individually. So for every EC2 server, or if every virtual machine, you need to have some sort of operating system disk, you want to have a CPU, and you need to have a memory. But if you want to put the additional any Java application, right, you need to increase those CPU and memory. So, and moreover, takes time to deploy. Still it takes time to deploy. That is also there actually, right? If you want to deploy, I need to go do all these steps and deploy. Of course it is fast, you can use like Terraform or something, but still it takes time to deploy. That means imagine if you want to deploy a complete virtual machine, at least it like 1 to 2 minutes. So can we, if you consider about like 10 virtual machines, it will take a lot of time. So how can we reduce that one? Now the container systems, right, going to solve these problems. The containers, right, does not have any sort of native operating system. That means container does not have any operating system. It needs the operating system, but it is not having any operating system. How exactly it's going to run, I'm going to explain. And it does not really require a lot of CPU and memory because it is not really running any operating system. So it's not having, and the time to take to deploy, right, is it's be very fast actually. Now fine, okay, where exactly these container systems are located? Now imagine I'm going to duplicate this one, but what I'm going to say is I'm going to create a new picture. In the new picture, I'm going to take from hypervisor, guys. I'm not going to draw the whole diagram, but what I'm going to do is I'm going to just take the hypervisor, only the green one. Okay, so I'm going to draw the green one. This is the hypervisor, and inside the hypervisor I have the red operating system, I mean virtual machines actually, right? So I'm going to draw them. So I'm going to just take one virtual machine actually. So what I'm going to do is, this is basically the hypervisor. Okay, next is this is the virtual machine or EC2. I'm going to say EC2, or you can also say that VMware virtual machine in your on premises. Now inside each virtual machine, what we are going to do, we're going to install a software basically called as Docker engine, guys. Docker engine, it's nothing but it is also one type of hypervisor. Basically it's nothing but it's a runtime environment. We can call it as CRI, stands for container runtime. C not instance, right? I can put it CRER. So container runtime environment basically. That means it will give you the application to run your container. That is what we're going to install. Short form we call it as Docker engine, guys. So what I'm going to do, I'm going to install the Docker engine on that one. Here this is basically the Docker engine. It's just a software, guys. You're going to use the yum and or apt and you're going to install it. So I'll say Docker engine. Okay, inside the Docker engine we're going to run the containers. If you see, we're going to run the containers. So I'm going to say a container here. So I'm going to say like container one, and I can say this is running Java, for example. And I can say this is container 2 running I can say like .NET. I can say this is container 3 running Python. Now this is what happening. Now if you see that you have a hypervisor, you have the virtual machine, and inside that I'm going to install the Docker engine, and inside that one I have container 1, container 2, container 3, which are running 3 different runtimes, guys: Java, .NET and Python. Now the question comes here. Okay, I told that the container don't have any operating system, but in order to run the container you need the operating system. So how exactly this able to run? So what is going to happen is when you run a container, this is what going to happen. The container simply going to use the underlying virtual machine operating system. Okay, it's going to use the underlying virtual machine operating system. So what it is going to do is whenever you run the container, right, basically it's going to use the operating system of the virtual machine, which is our EC2, and then it's going to run your container. Now to understand more about this one, right, you need to understand, let me show it to you. I'll say what even is a container. I'll say Julia events, for example. Okay, now don't ever think that containers are very new. Actually containers is there as which is as a part of a Linux from a long time. But what exactly Docker did was Docker actually simplified it and make it user friendly. That's what they did. Now what exactly is container? Container is nothing but very simple. It's a namespace and a control groups. That's it. So container is nothing but a namespace and control groups. Now this is there in Linux from a long time. What exactly it will do is, what is a namespace actually? Namespace is nothing but, let me compare something like, so if you have a home, actually imagine you have your home. Actually this is your home and you have 4-bedroom apartment, for example. So I'm going to do something like this. Okay, now this is a 4-bedroom, right? Each room you can actually call as a namespace. So what exactly namespace is doing? Actually namespace is actually giving the isolation, guys. So namespace and namespace, and finally this is the namespace. So it is giving the isolation. Now here what is the from what exactly, if it is a flat, right? So the person will be there in one bedroom, will be have isolated from the person from the other bedroom, right? That is what isolation. Now what exactly happens in case of Docker? Actually it is nothing but a process, right? It is a process. Whenever you run something in a container, so whenever you run something in the Linux, right, everything has a process ID. Okay, so what exactly namespace is? Let's say you wanted to have like a virtual machine. One of the feature you is my process should be separated from other process on the computer. One feature provides is namespaces. There is a bunch of different kinds. Okay, you have a networking namespace, you have a mount namespace, you have a PAD namespace. So what exactly it will do is every container is just a process, guys. See what we are thinking, that means okay, this is container 1 2, this is container 1, this is container 2, this is container 3, this is container 1 2 3, and for ourselves actually as administrators we see that as a container. But simply, you know what Linux will do? It will just see that as a process. So what is a process? If I right click and go in Windows, right, if I go to task manager, these are all the processes, notepad process, paint, these are all the processes. Similarly, a container is simply seen as a process by a Linux machine. Once the process completes, it will terminate the container. Okay, now what it will do, this namespaces will create separate processes. There is no relation between each one. That is a container. Okay, so what it will do, I want you to guys to read this one, then you understand what exactly is a container. Now what will say, the PID namespace, you become a PID1 and then your children are the other process, all other programs are gone. Now this is a old actually. So entering the namespace or other program, what we'll do is normally this is there for NS Center. What we're going to do is we're going to use Docker exec to do that one. But simply put, namespace is something like a different process, guys. So let me log into the server. Okay, let me, so a lot of, so let me close it, guys. Okay, hold on. I just completed the DevOps class. And, give me 1 minute. Let me close this. By the way, we're going to complete by 10:30, and let me tell you, I'm going to use only this video, first class, right? I'm going to make it into 3 parts, and I'm going to share on the YouTube. The reason is only this class, right? Because I don't have any DevOps videos for English, guys. So the plan is to take first video of all and share on the YouTube so that they should understand the way of teaching and everything. Or if some student want to come to talk to me, all these things. Okay, so don't feel offended because I'm not going to share everything. So just only the first video. Right, so let me log in. So it will be Ubuntu. Okay, so let's see what are all the process it is running. So I'll say ps-ef, right? If you type, these are all the process running, guys. If you see, normally these are all the PIDs actually. So what will happen now, whenever you run a container, basically it is considered as one of the process. That's it. Linux really don't know about virtual machines, all these things. Simply it will be considered as a process. So, and it is run in such a different way, it runs in isolation. That means there won't be any sort of connectivity between the processes. So normally if you want to talk to that process, right, in Docker we're going to use something called as Docker exec, and you're going to talk with that process. So that is what a namespace is. There is also namespaces in Kubernetes also, which we're going to talk later, not in this course by the way. But namespaces are nothing but it provides isolation between the processes. Very simple. Now, as I said, container is all about namespaces and C groups. Okay, namespaces, as I understand, it provides if you deploy multiple containers, there should be some sort of isolation. They should not communicate with each other. That is what a namespace is. Fine. What exactly is C group? C group stands for control groups, right? Which is nothing but resource allocation. That means I need to tell, right, how much RAM you can utilize, how much CPU you can utilize, right? That is what here, which is nothing but resource limits. So we have made a magical world with a new processor and sockets that is separate from our world. Cool. What if I want to limit how much CPU the programs are using? So in 2007, people developed C group just for us. These are like a nice process, but with a bunch of more features. So what will happen is, uh, you can actually provide how much CPU you want to use as well as how much memory you want to use using the control groups. So just see all these things, guys. So what are containers then? Now that you've seen the two features, I could build a bunch of scripts around these features and have something really cool. Okay, so if you want to know about namespaces and as well as C groups, I create scripts, I manage some separate process. It's not required actually. So some people thought it's a positive. They have built something called as Docker containers. Okay, so that is all Docker is. Docker is nothing but simply, okay, simply but see, Docker has a lot of features. This is, but it is not built in basic kernel primitives. That means the primitives are nothing but your namespaces and control groups. So what Docker did, Docker simply simplified it to make it user friendly to create the containers. Instead of doing all these things, it make it very simple. So coming back to again to recap, right? So the containers will be, if you want to run the containers, you need to have a Docker engine, which is a software or application which is installed on a virtual machine. You can also do it in physical machine also, guys. No one is telling you need to do it in a virtual machine. I can say you can do it in a physical machine. Then you are actually working in 1980s or 1990s, because no one is using nowadays physical machines apart from government entities. Okay, most probably people are using cloud and virtual machine at least. So that's why I have given hypervisor virtual machine. Inside the virtual machine you install the Docker, and inside that one I have created the containers. But if you want to say that you're not using you're having a separate data center, you really don't want to use the hypervisor, right? You can simply install the Linux and install the Docker engine on that one and start using it. No one is going to say it is wrong or something. Okay, so now I'm going to open a picture and show it to you. So I'll go to Google. Sorry, containers. I'll say versus virtual machines. If I go to images, right? So I'm not going to waste much time on explaining about what is the difference, all these guys, because that's why I'm going to use only half an hour to explain the overall stuff. But you have a lot of things you can actually get in the Google to understand the difference actually. But simply put, so Linux has these containers from long time. Okay, Windows is also supporting right now, but you see most of the people are using on Linux only. And now the containers is going to utilize the underlying operating system. So if you see in this picture on the left side, you have the infrastructure. Basically, if I say infrastructure, you can actually say that one. This is okay. Why this is not working? Okay. Okay, so if you see here, hypervisor infrastructure is there. Infrastructure is nothing but your virtual machines or cloud, whatever it is. On that one you have the hypervisor. Normally on the hypervisor you're going to have guest OS. These are virtual machines, guys. Guest OS is there, right? These are our EC2 virtual machines, and we need to install the binaries as well as libraries like Java, JDK, all these things, and then over that you need to put the application. One thing you can see here is there won't be any guest OS here, see guys, because the guest OS is nothing but operating system. Here on the virtual machine I can install the container engine, and I can directly install the binaries and the application. What happened to the guest OS? Because I really don't need the guest OS, because the underlying operating system will be used by the containers. So the operating system is there, right? That's why you have like a Linux servers which will be deployed with Docker containers, and applications will be using that operating system. It does not require any operating system drives, RAM, CPU. Since what I'm trying to say is, here in the picture, on a container you really don't need to have OS disk, because it's going to use underlying EC2 or virtual machine OS. It really the container really no need to, it's not going to use a much of a CPU or memory. It will be very fast. And the biggest thing is the time to take the Linux containers, I mean sorry, the Docker containers or containers, right? It will be very fast, guys. It will be matter of seconds if you are deploying the containers. Whereas if you want to deploy the virtual machines and delete the virtual machines and everything, right? So it will take some time, right? To deployment will take some time, but that is not the same case in the containers. It will be very lightning fast, and then even deletion also, it will be deleted very fast. So what exact, okay, fine, I explained, okay, this is virtual machines, and this is containers. What exactly the use for these containers basically? See, the container systems make things deployment very easy. I can say rather than easy, I can say like it will be very fast. So, and it will also reduce your cost also, because you really don't need to run a lot of servers, which can give you a lot of cost. What you can do, you can take a bunch of servers and run hundreds of containers. Let me tell you my record. I tested it on a T2 virtual machine, guys. On a T2 virtual machine, I ran 150 containers. It is having 1 GB RAM, guys, but still I managed to run 150. Of course, there is no load, but still I managed to run 150 containers to test out how long it can withstand. So what will happen the moment if you go to the containers, right? So you don't need to use the physical servers or virtual servers, which can save a lot of money, as well as implementation will become very easy. Testing also will become very easy for you. So in easy way, in easy words, right, it will saves a lot of money, and deployments and operations, everything becomes very easy. So this is the major difference between virtual machines as well as the containers. Any questions, guys? Are we clear? Yes, no? Okay. Now, this is what we're going to do. What we are going to do is, 1 minute, guys. I'm noting down something. Okay. Now what we're going to do is, I'm going to take the Ubuntu machine which we have configured. Okay, and I'm going to install Docker on this one. Now if I type Docker, right, simply it is simple say the program Docker is currently not installed. You can install it by typing apt install docker.io. Don't do that. When you install using apt install docker.io, that means you are installing a old version. So from where I need to install, let's follow the process here. So I'm going to here, I'll say docs dot doc sorry docker.com. Say docs.docker.com, and I'll say get docker, and you'll see in the Linux, right, what we want is Ubuntu. And if I go to Ubuntu, you can see like it is supporting 16.04, 18.04 and 19.10. So LTS long-term support, guys. LTS means it's a long-term support. Okay, so it qualifies. The one we are using is done. So let's check it out. I'll say cat etc lsb release. It is saying that one. Okay, I'm using 16.04 and Xenial, and it is using the 16.04.6 LTS. So it supports actually. Good. Now, what are the steps I need to follow? If you already have Docker installed, you need to use these steps to remove it, but I already checked it, we don't have any Docker. I'll go down. Now first is we're going to run the Docker update, and then we're going to install these basic packages, and then we're going to, as the gpg key, run one more time Docker update again, and we're going to add the repository, run the update, and then install the Docker. This is what we're going to do. I think it is 1903 something, but we'll check it out. Okay, let's do step by step. Step one is perform a apt-get update. Copy this, give it here, run it. It's very easy to install it, guys, so not a big deal. But okay, sorry, yeah. Next is, you can actually make this into script and install. I can do that as well, but I want to give you the way how to do that everything. I don't want to do a script so that you'll get confused. So I just do the manual things. And what you can do is you can convert that into a AMI image and do that one. Okay. Right. Come down again and fingerprint. Guys, let me tell you, learning Docker as well as Docker Swarm is very, very important if you want to go to the Kubernetes. Okay, so many people directly go to the Kubernetes. They don't understand how Docker works, what is the underlying components, everything. They don't understand. They finally end up learning some creating of some pods or service. That's it. They don't understand it. So if you understand, the reason I started from virtualization is because you should understand the base component, from where we are coming and where exactly the containers are coming, and how we can deal with this one. So if you understand this, Kubernetes will be a cakewalk for you. Okay, let me run the, I don't say so much of easy, but you will easily understand because you're going to compare the Swarm with the Kubernetes. I'll let you know once I start. I have